Have you ever wondered what happens when one service succeeds but another service fails in a microservices application? Imagine this situation. Your order is created successfully. Money is deducted from your account, but inventory update fails because stock is unavailable. Now the system has inconsistent data. Order exists, payment is completed, but product stock was not updated. So how do companies handle this problem in distributed systems? This is exactly where Saga Pattern helps. Let's understand Saga Pattern in a very simple way. In a microservices architecture, an application is divided into many small services. Each service works independently, and each service usually has its own database. Now imagine one business operation needs multiple services to work together. For example, placing an online order. Usually, multiple services are involved. The order service creates the order. The payment service charges the money from the customer. The inventory service reduces product stock. All these steps together form one business transaction. Now we will see the main problem. In traditional applications, we use a database transaction. The transaction guarantees two things. Either all steps succeed or all changes are rolled back. This approach works well in monolithic systems with one database. But microservices work differently. Here each service has its own database. Services are independent from each other. Because of this, one single transaction cannot control all services together. So now the big question becomes, how do we keep data consistent across multiple services? Now we will see what is the Saga pattern. The Saga pattern is the method used to manage distributed transactions. A distributed transaction means one transaction that involves multiple services. Instead of using one large transaction, the Saga pattern breaks the process into many small transactions. These small transactions are called local transactions. Each service performs its own local transaction using its own database. After completing the task, the service informs the next service to continue the process. Now suppose something fails in the middle. In that case, the system performs a compensation action. A compensation action reverses the previous successful steps. Now we will see the important concepts. First one, distributed transaction. A distributed transaction involves multiple services instead of one single system. Second one, local transaction. A local transaction is a small operation handled by one service and its own database. Third one, compensation. A compensation action undoes a previously completed step when something goes wrong. Now let's see how the Saga pattern works step by step. Imagine this simple flow. Step 1. The order service creates the order. Step 2. The payment service processes payment. Step 3. The inventory service updates stock quantity. Each step happens one after another. If everything works, if all services complete successfully, the transaction is completed successfully. Everything remains consistent. If something fails, now imagine payment processing fails. The system cannot continue normally. So the Saga pattern starts compensation actions. The order service cancels the order. Any completed steps are reversed. This process helps the system to return to a consistent state. Now we will see the real life example. Suppose you book a travel package online. The system performs three steps. First, flight booking. Second, hotel booking. Third, cab booking. Now imagine flight booking succeeds, but hotel booking fails. What should happen now? The system should not keep the flight booking active. So the system cancels the flight booking. The cancellation is called a compensation step. Even though services work separately, the overall system becomes consistent again. Types of Saga pattern. There are two common types of Saga pattern. First one is choreography based Saga. In this approach, there is no central controller. Each service listens for events and decides what to do next. For example, the order service creates an order and publish an event. The payment service listens to that event and processes payment. After successful payment, another event is published. Then the inventory service listens and updates stock. So services communicate through events. No single service controls the entire process. Second one is orchestration based Saga. In this approach, there is a central controller called an orchestrator. The orchestrator manages the entire workflow. The orchestrator tells each service what to do. For example, the orchestrator first calls the order service, then the orchestrator calls the payment service, then the orchestrator calls the inventory service. If any step fails, the orchestrator triggers compensation actions. So the orchestrator controls the complete process flow. Why the Saga pattern is useful? First point, keep services independent. Each service manages its own data and database. Services remain loosely coupled. Second point, works without global transactions. No need for one large database transaction across all services. This approach fits microservices architecture very well. Third point, handles failures properly. Failures are managed using compensation actions. The system can recover safely from errors. Fourth point, scales well. The Saga pattern works well for large distributed systems with many users. Now we will see the summary. In microservices, one big transaction usually cannot be used across multiple services. The Saga pattern solves this problem by dividing the process into smaller local transactions. Each service completes its own work. If something fails, compensation actions undo previous successful changes. This approach helps maintain data consistency in distributed systems. One line understanding. The Saga pattern is a way to manage multi-step operations across multiple services by using small transactions and compensation steps instead of one large transaction.